Today we'll be discussing the relay. When we're done, you should be able to discuss the basic parts and the operation of the relay. We'll be able to identify the relay by how many poles and how many throws it contains. We'll also go over some basic circuit troubleshooting of circuits that have relays. Here we see the schematic symbol for a relay. This particular relay is a single pole double throw, and we'll talk more about that in just a little bit. Inside the schematic symbol, I want you to notice that we have a couple of contacts. Okay? These are contacts. This particular one here is called a normally open contact. We usually use NO for that. This contact is normally closed. Also inside the schematic diagram you can see this. This is our coil. This is what we're going to energize, and when we do, it's going to switch the normally open to normally closed. It'll change the normally closed to normally open. This is one symbol that you might see for the coil. These are also other symbols that you might see in a diagram representing the coil in a contactor or in a relay. Here we see a 3-pole relay. It's a double throw on each one of them. If we look right here, we can see the coil. When I energize the coil, you'll see the contacts move to the down position. Now we'll talk about poles and throws. When we talk about poles, we're talking about the number of inputs coming into the relay, and the throws would be the number of outputs per each pole coming in. Let's take a look at several different examples here. Here we can see where we just have 2 inputs and each has 1 output. This is called a double pole single throw. Here we can see one where we have 1 input and we have 2 separate outputs. This is a single pole double throw. Here we can see one where we have 3 inputs and 1 output per each pole, or per each input. This is a 3-pole single throw. This one, we have 2 inputs. Each one has 2 outputs. This is a double pole double throw. This one has 4 inputs. Each one has 1 output. This is a 4-pole single throw. So once again, when we're talking about a relay, it's important to understand how many input lines we have and how many outputs per each input. It's not how many total outputs, it's how many per input. Here we can see one type of relay. Notice that on the right side there are 2 poles that are hooked together by a piece of metal. Here's the schematic symbol. How many poles and throws does this relay have? Here's another type of relay. You can see how the inside of it is laid out. Here's the schematic symbol. How many poles and throws does this one have? once again, you can see how the contacts are laid out. Here's the schematic symbol. How many poles and throws does this one have? And this will be the last one. Notice how the contacts are laid out inside of the relay. Here's the schematic symbol. How many poles and throws does this particular relay have? Here we can see a small circuit with a relay inside of it. This particular relay has one input, two outputs. This is a single pole double throw. What we're going to do in this circuit is we're going to have our power coming in. We're going to have 115 volts coming in. We're going to bring that directly into the single pole. To make this particular relay work, the coil voltage for this is 24 volts. We're going to use a transformer to step down the voltage from 115 down to about 25, 26 volts. We'll have a switch so we can control when we turn that on and off. When we first plug in the circuit, why this switch is open, what's going to happen is this is normally open, so this lamp is going to stay off. This one is normally closed, this lamp will come on. When we close the switch, that's going to make this one close, which will turn on lamp 1, and that'll make this one open, which will turn off lamp 2. Here we can test out the circuit that we saw the schematic for. Basically, here's our power coming in. This is line 1. It goes directly to the pole of this relay. Coming out of the relay, we have a normally open and a normally closed contact. Here's our normally closed contact. It's the white wire. It's going to lamp number 2. Here's the normally open wire. It's the black wire going to lamp number 1. The green wires go to our switch and to our transformer. That's going to give us our 24 volts. We're going to start by applying power to the circuit. When we do, we can see that lamp 2 lights up. That's because the power comes into pole number 1. It goes through the normally closed contact right to the lamp. We can prove that by taking a voltage measurement. We can see that if we go over here, we have 114.6 coming in. We go over here and we're getting our 114.6 coming out, and that's what goes to the lamp to make it light up. If we look at the normally open contact, you'll see that we don't have any voltage coming out of that. Now when we flip on the switch, what's going to happen is the coil inside of there is going to make that contact close, and the normally closed one is going to open. So let's switch this on. When we do, now we can see that our normally closed contact is now open. We go over here, we get 0 volts. We go to the normally open, and we can see that now it has the 114.6 volts. So it's getting the power now. That's why this light is coming on. Remember that whenever you have a relay, whenever you energize the coil, the contacts are going to do just the opposite of what they normally are. So the normally open will close, and the normally closed will open. At this point, we're also going to check our voltage on our coil. The coil in this particular one is a coil that runs off of 24 volts. So if we measure across the coil, you can see that we have our 24 volts. We got 26.4. Okay, so that's what's making it run. When we turn the switch off, you'll notice that our voltage drops to 0. Okay, so when it goes on, we got our 26. When it's off, we have 0. Okay, if we have 0 volts, it can't make those contacts switch inside of there. Here we see another circuit. This one has a single pole double throw. Here's the pole on this one. This is our L1 line coming in. This is our power coming in. This is the normally open contactor, the black wire. The white wire is going to be our normally closed. So when we first apply power to this, and we don't have our 24 volts going to the coil, the power is going to come in, it's going to go straight over to the normally closed contactor, and it's going to turn on lamp 2. Let's turn on the power. We can see that's exactly what happens. When we go over here to the pole, okay, our L1 coming in, you see we've got 114 volts. You'll see that our normally open, we get 0 volts. Normally closed, we get our 114 volts. Power is going through there. When we energize the coil, that's going to send 24 volts to the coil, and that's going to cause the normally closed switch to shut off. So we'll get 0 volts there. We'll go to the normally open, and you'll see that now we have the voltage going through. That's why the light lights up. Like I said, it all has to do with that coil. Okay, we have to have our coil voltage. So let's take a look at the voltage on the coil. And you see that we have 26 volts. Okay, and that's typical on a 24 volt transformer. If you're only hooking up 1 or 2 devices, you'll get 26 volts. So we've got our voltage there. When we turn it off, you'll see our voltage drops out. Here we see a double pole single throw. So there's 2 different inputs and 1 output for each one. This one is a normally open contact. This is a normally closed. If I hook up the power to the normally closed, lamp 2 lights up. If I hook it up to lamp 1, it does not come on. So I can make it come on. I can make it switch by applying my 24 volts to the coil. And at that point, if I switch back here, this one will not work. Once again, this is a double pole single throw. We could rewire this to make it a single pole double throw. We just need to hook up another wire at the same potential as this wire here. So I'm going to turn off the camera. I'm going to hook up a second wire to L1, and then we'll take a look at it as a single pole double throw. Instead of having a double pole single throw, I'm going to change this to a single pole double throw. All I need to do is add a second power wire coming in so that both of these inputs have the exact same amount. Now, whenever I turn the switch on and off, it'll cause the lights to work like a single pole double throw switch. We have 1 input coming in, that's our 114 volts. Coming out, we have our normally closed and our normally open. To make those switch, we just turn the power on, so we send 24 volts to the coil. Poles equals the number of inputs. Throws equals the number of outputs per pole. Normally open will not pass current until the coil is energized. Normally closed will pass current until the coil is energized. If the coil voltage is applied and the contact for each throw does not switch, the relay is bad. If you found this video useful, make sure you like, subscribe, or comment with any ideas that you might have for other topics.